Am I audible? Yes. Yeah, Sanjshi, I'm fine. Just my throat has been a bit sore. Otherwise, I'm good. Hi, Dhruv. We'll start now. Yeah. Good afternoon. And thank you all for being patient with me. It's not a usual thing. I taking off if I'm not well. The worst thing I fear is when this break extends, invariably the momentum gets impacted. ना आप एक फ्लो में पढ़ रहे हो या पढ़ाई कर रहे हो, in one flow you are managing a routine, and one of these breaks can disrupt the routine. That is one big scare for me, but okay. I'm fine, but I'm fine. I'm fine. My throat is more affected, but we'll see. No issues. Okay. No. It's nothing of that kind. Asking me about whether I am asthmatic or not. I used to be, not now. When I was back in my earlier days as a teenager and in college, yes, I was severely asthmatic then. But अब नहीं है. I mean, thankfully, thank God, blessings. चलो ठीक है. Let's get back to our discussion of interiors of Earth. We revise quickly first. It's been a while, so some quick words for recall. Earth is a terrestrial planet. It is the densest planet. It is layered, and I had referred to the nebular accretion process. Okay, and I mentioned a phrase, gravity collapse. याद आ रहा है ये वाला? When you are talking of gravity collapse, it basically means the denser matter, the heavier matter that falls inside, वो अंदर रह जाता है, and the lighter matter will be outside, will be outwards. Okay, so this has resulted in a progressive increase of density with depth. And while discussing this, I had said iron, magnesium, nickel, these are heavier, and they make up the bulk of interiors, but not abundantly found in the outer layers. ये पॉइंट समझ में आया आपको, all of you? Iron, magnesium, nickel are heavy elements, and much of the Earth's mass is because of this. But if you analyze the composition of the outer layers, इसको हम बोलते हैं crust. The crust does not have much of magnesium. The crust has some amount of iron. Okay. The crust has some amount of nickel, but in the crust, we have dominance of silicates. We have dominance of aluminium. Okay. So I presume you understand this particular idea. Don't just mechanically memorize percentage, have a sense of how that content is organized. कहाँ पर कैसा है? Okay, Earth's interiors are layered, Earth's interiors is not one single rock, layers हैं. In the layer, as you go down, it becomes more and more dense. The heaviest elements, जो अगर आप inner core देखोगे, inner core's density of 11 and 13. 13.5 is the weight of iron. 11.5, 11 is the weight of nickel. The core density corresponds to the density of iron and nickel. The earth is majorly made up of heavy metals, but in the surface layers, we don't have iron and magnesium much. We have more of lighter elements, silicon compounds, oxygen compounds, aluminium, and so on. Okay, I hope all of you understand this. Yeah, all good? Online, you must keep telling me if you have any problems. Venkatesh, I'm good. I'm good. Chalo, good, nice. So, linked to this, I can also revise quickly that the dominant minerals of the Earth's interiors. ये क्या minerals हैं? Okay, minerals are silicate minerals. There is a group called as the silicate group. Silicate group of minerals. And in this silicate group, there are lighter ones, which we have called as felsic, which we call as non-ferromagnesium silicates. And we have the heavier ones called as mafic, called as ferromagnesium silicates. The felsics, they make up the outer layers, they make up the crust, and these make up the mantle and the deeper layers. And I gave some names: amphibole, pyroxene, olivine. And again, it's more for a grounding concept. I don't think they'll ask you, but know these terms. It doesn't look nice. Geography optional, you are struggling with some basic terms, okay, of minerals. All fine here? Yeah, that's okay. Can I move on? Can I move on, all of you? Is it good? Okay, good, nice. Okay. So, Earth's interiors are layered. Then we said there are different schemes. Or rather, sorry, there are different aspects of Earth's interiors. I can discuss in terms of density patterns and composition patterns. I can discuss in terms of temperature patterns. Okay. We can talk in terms of rigidity patterns. Okay, so alag ways how I can discuss the interiors. So we had one discussion on temperature pattern. We said interiors are hotter. I used the term the residual gravity heat. When Earth was forming, Earth was becoming solid. Some amount of mass converts into energy. It's a very basic fusion reaction बोलते हैं इसको. For those not initiated, if I take 1 gram of something, I take another 1 gram of something. If I have a fusion reaction, okay, 1 gram and 1 gram will not become 2 grams. It will become 1 point something. और जो extra part रह जाता है, it becomes energy. What we call as mass effect. Okay, so when gases are combining, fusion reactions, when they combine to become solids, energy banega usse. Energy will be created. The nebula, when it was accreting, it was forming, lot of energy must have come out. Lot of energy has been lost now. Earth is almost 3 to 4 billion years old. Energy lose bhi kar raha hai. But some amount of energy is still inside the interiors. We call that as the residual heat. It is a source from when the nebula was converting into the planet. But then we said we also have radioactivity going on. Abhi bhi chal raha hai radioactivity. So this residual heat is not uniformly distributed. We have some facts there. Wherever we have geothermal activity, we have seen temperatures can touch around 1000. In parts of inner mantle, 1000, 3000 types. In the inner core, temperatures can touch 3000, 4000 types. And the inside core, it can be as much as 5000, 6000 centigrade. The numbers, then the book, I'll show the pages to you, have a broad idea. Okay. Otherwise, there's no rate specific how it increases. So I'm done with temperature understanding. Then, okay, density bata diya aapko, how it increases with depth, how the nature of composition is changing from non-ferromagnesium changing towards ferromagnesium. No, nebula is not a gas. Nebula is a cloud, Anugya. Cloud mein gases hain. The cloud will have gases, the cloud has ice, the cloud has dust particles, the cloud has neutrinos, okay, the cloud has certain unknown matter, which in physics we call as the dark matter. Okay, so cloud is not a gas. The nebula is not a gas. Nebula is a cloud. It is made up of gases and dust particles and ice crystals and, as I said, neutrinos, some unknown dark matter. Okay, all of that becomes nebula. Short forms hai Halima. Okay, mafic. Okay, magnesium and iron. Felsic. Okay, Fe is iron. Si is silicon. Taken short forms of those terms. Okay. Okay. Yeah. So temperature done, density you understand. Then this layering scheme, there are different schemes. There are different schemes. How different people have thought about the layers. Like I said, no, interiors 6400 kilometers. Till that depth, it's not possible that you can physically go and check what the interiors are. So much about what we know, much about the earth that we know, is because of some indirect measurements, and different people have interpreted differently. Okay, so I gave you 4-5 names. What did Edward Suez tell us? What did Arthur Holmes tell us? What was the model of Daly? What was the model of Van der Graaf's model? Graaf's model, and different names, Sial, Sima, Knife, Grandiorite. Okay, go inside, we have got amphibolite, we have got ecolgites. Bas naam jaan leej, nothing else. Daly talks about outer silicates, inner silicates. Okay, the model which Van der Graaf gave us, this model is closest to how we see the earth today. So I didn't mention it last time, I can do it today. I always recommend open the books after you have studied the class notes pehle. Okay, don't, and clarification, if you ask this to me. These books are not to be read cover to cover, page by page in every sentence. It's nice if you know all the content, but that will impact your progress. आपको सिर्फ geomorphology नहीं पढ़ना, ये किताब पढ़ने में आपको लग जाएगा 2-3 महीना. It doesn't make sense. So I will be guiding the process to you. Okay, some pages, some diagrams, some sections, and I'll keep telling that to you. So in your textbook, there is this page. Yeah, there it is. Page number 109, 110. If you have your book with you, okay, आप लिख लो notes में, बाद में देख लेना. Page 109, page 1010. So it's here. You can see this. Uh, here we are. So page 109, page 1110. There's something here. What does daily tell us? Daily scheme. Okay, then we have according to Arthur Holmes. दिख रहा है आपका Arthur Holmes यहाँ पर? Then you have the model by Van der Graat, and he talks about outer sialic layer, inner silicates, zone of mixed silicates, zone of metallic nucleus, and these values I've mentioned, but I round that off. ये बोलता है 1140, 2900, I said 1000 to 3000. Okay, it says 3.1 to 4.75. I just said 3. Okay, so I have rounded off the numbers there. Okay, so just know this much. That's all. Okay, 4-5 names of what are the schemes, and okay, the more important one is what I have been discussing as a part of the contemporary models of your composition and rigidity. Okay, that's your reference. Just 2 page padna hai aapko, don't go beyond that. But yes, this is a nice information in page 104. Page 104, the chapter beginning, chapter 5 ka, a nice page here. Okay, it tells you about how we know what is the Earth's density, what the core density. Some facts are mentioned here. Just quick reading, nothing that you have to be focused about. Then page 106 has something on the temperature patterns. Page 106, temperature patterns. यहाँ पे लिखा है देखो. The asthenosphere is molten. The temperature depth of 400, 700, 1500, 2000 के range में है. As you go into the mantle, deeper mantle, then the core is 5000, okay, 4300. So I've round off all the numbers. Okay, these 4 points are good enough. What is the trend of the temperatures inside the interiors of the Earth? This is page 106 in your Savindra Singh. Padma, I'm just revising right now. Okay, I'm just there's been a break, that's why. All done, all of you? So now we revise quickly. What is the chemical composition? Core, mantle, crust, mantle, and the core. The crust is 2 types, oceanic crust and continents. ये बहुत important learning है. Crust is what? Crust is the outermost layer of the Earth. An outermost layer, we have got 2 types of features. We have the oceans and we have the continents. When I say oceans, I don't mean the ocean floor, ocean water. I mean the ocean floor. So imagine this is the continent, okay, and the ocean basin, which aisa hai, and this is the water in the oceans. I'm not studying this one. I'm studying this one here, this layer. This is the ocean crust. And this is the continental crust. So unlike our understanding or assumptions earlier, okay, the oceans are not extensions of the continent. Oceans are not the submerged parts of continent. Oceans बहुत अलग है. One analogy I give you is, imagine we have a house. Okay, I have a portico. The portico has some tiles. उसके बाद में it is grasses. I have a lawn. So this portico floor does not become the lawn. They may be at the same level. Portico is stones, portico is plastered, portico has marble, okay, portico has tiles, and the lawn is the grasses. It's of grasses. We can't say the lawn is extension of the portico, right? So the composition here, this is stones, this is tiles, marbles, और ये soil है. दोनों अलग चीज है, right? तो वैसे सोचो आप that the continents doesn't extend like this. Continents end somewhere. When I say continent, I mean what? I mean looking at rocks like granite. I'm looking at rocks like, okay, andesite बताया था आपको, very common rock of the continents. A very common rock is diorite. These are continental rocks. These rocks are lighter, not as dense. These rocks have density of 2.5. These rocks are hard rocks, but they are lighter, halka. Hard hai aur halka hai. These rocks are acidic rocks. Continents are thick. The thickness of continents can be 60 kilometers. In some places, they can also be about 80 kilometers thick. The continents, okay, and oceans are not same thing. The ocean floor is different. Ocean floor is basalt, I said. Basalt is not a hard rock. It's a relatively soft rock. Basalt is basic. They have density of 3.5. Okay, that's how the outermost layer is two types of, okay, compositions. Likho na, no problem. You can draw this. You want to draw this. Go back to last class notes and you can have a small sketch. Okay, what are the continents? Okay, what is their composition, the nature, and what are the oceans? What is their composition? What is their nature? The continents. Continents, I said, are likha hai aapne already. Granite. Continents are andesite. Continents are diorite. Continents are lighter. They are harder and they are acidic. How can something be hard and yet lighter? Hard is a measure of rigidity. Lighter is a measure of density. दो अलग चीज है. Okay. Example, mercury. Mercury is very dense, but mercury बह जाएगा. It flows. Okay. Think of glass, जो आपका शीशा है, windows में glass. Okay, glass is lighter, but glass is hard. वो टूटेगा, वो bend नहीं होगा. Okay, so light or not light is a measure of density. कितना matter packed है per unit volume. Hardness is a measure of rigidity. Okay, so both are different. How to separate them? Why do you need to separate them? हो चुका है already. Not joint. There is one transition there. There's no joint as a joint, but yes, there's somewhere they kind of use. Yes, oil. Correct. Oil is dense. Okay, but sorry, oil is thick, but oil is lighter. Okay, oil floats on the water. Oil thick होता है. Okay, but हल्का होता है. Yes. Okay, fine. You know the examples now. Is it okay, all of you here? That's the difference between. So ये जो process है ना, we call this process as crustal differentiation. ये बहुत important concept है. Called as crustal differentiation. The word differentiation means how do things separate out? अलग कैसे होते हैं? How do they become different? How does the ocean become different from the continents? How the ocean separates out from the continents or vice versa. It's called as crustal differentiation. Okay, this is responsible for the creation of the crust. Okay. So that's about the crust. Details bata hai. Mantle, I said, the thicker part. Mantle is 80% by volume of the earth. Mantle is 60% by mass of earth. Mantle starts below the crust, goes up to 2900 kilometers. So, a very thin layer of crust, and then is a huge part called as mantle. Okay, this is from यहाँ से यहाँ तक. This is 2900 kilometers. इसके बाद में the core starts. और core के फिर दो parts हैं. The outer core and the inner core. So, mantle is a thick part. Mantle के फिर there are different divisions. We know three of them for now. The upper mantle, the middle mantle, the inner mantle, also called as deep mantle. And we have some values of differences. Density इसका approximately 4 है. Okay. यहाँ आते आते 7 है, 9 है. I come to core becomes 11, 13 and so on. Some of these numbers you should know. As you go down, it becomes more and more denser. And the main rock of the mantle is something called as dunite, or we have dunite rocks, we have spinal rocks. Okay, the dunite is common, and one type of mineral called as olivine is very common. Olivine, this makes up the mantle. Core, you understand, outer and inner. Outer core is more fluid, inner core is solid. So you're asking me, okay, why is, oh, what happened? Yeah, there's a power outage. Please bear with us. It should be back. Hopefully. Something is not right this week, right? कुछ ना कुछ हो रहा है. कभी मैं out हो जा रहा हूँ, कभी बिजली out हो रहा है. So, okay. So let me speak while we are discussing or revising. So, talking about this, why the interiors are solid, the core is solid. The interiors, जो solid या liquid होता है feature, it's a consequence of two things: temperature and also density. Okay, melting point. Melting point depends on temperature, composition, and it depends on the pressure. As they go inside, the pressure is so much. Essentially, liquid or solid में difference क्या है? In liquid, the atoms are a bit far apart. In a solid, the atoms are together. If I have a mechanism where the atoms can be kept together, okay, even if I heat it, they will not become liquid. So it's called as something called as a pressure freezing bolte hain. Because of immense pressure on, okay, the core, so high pressure that even at high temperatures they won't melt. And I was reading somewhere, the pressure at the core is approximately 3.5 million atmospheres. What's the pressure at the sea level? 1 atmosphere. The pressure of 1 atmosphere, that is approximately 76 centimeters of mercury column. At the core, the pressure is 3.5 million atmospheres. Utne pressure mein, okay, the whole thing remains solid. We call that as pressure freezing. We call that as pressure freezing. And in the outer core, there are impurities. The impurities can be responsible for lowering the melting points. So एक part लिख लेते हैं. Add on one small discussion add here. Give a subheading. Why is the outer core fluid and the inner core is solid? Why is the outer core fluid and the inner core is solid? Head down. The inner core experiences very high pressure, approximately about 3.5, very high pressure, approximately about 3.5 million atmospheres. 3.5 million atmospheres. This increases the melting points. What's the meaning of increased melting point? मतलब क्या है? It will melt at a higher temperature. It increases melting points. ठीक है? Therefore, even at 5,000 centigrade temperature, even at 5,000 degrees centigrade temperature, the inner core remains solid. The inner core remains solid. Okay. This is called as pressure freezing. This is called as pressure freezing. Next, go. Outer core also experiences high pressure. Outer core also experiences high pressure, but iska thoda kam hai. It's around, I think, 1.4, 1.5 million atmospheres. So approximately 1/3 of what we have, okay, for the inner core. The outer core experiences about 1.5 million atmospheres. Okay, and the outer core has silicate impurities. The outer core has silicate impurities. Then bracket mention, presence of impurities will reduce melting point. Presence of impurities will reduce melting point. So if you add impurities into a metal, okay, it will start melting at a lower temperature. Okay, write down that outer core is at around 3,000 to 4,000 degrees centigrade. Is at around 3,000 to 4,000 degrees centigrade. And therefore it is molten. Therefore it is molten. Is it okay, all of you? Okay. So see, I'm sure there are more complex reasons, but for our level, this is fine. Okay, we don't enter too much of geophysics ki kaise ye impact hota hai. Okay, in general, metals ka ye behavior hai. It is molten, Pritha. Outer core is therefore molten. Okay. So that's okay. Revising the discussions of last class, and I had mentioned the discontinuities, right? Okay, the Conrad, the Moho, Gutenberg, Repiti, Birch, then Gutenberg, then we discussed Lehman. Gutenberg and Lehman discontinuity differentiates or separates the solid inner mantle from the fluid outer core. Layman separates the fluid outer core from the solid inner core. इसीलिए इन दोनों को बोलते हैं they are phase discontinuity. The two discontinuities, they mark change of state, liquid solid, solid liquid. They're called as phase discontinuities. One of you asked me this, what is that? तो अलग से कुछ नाम नहीं है, just a name of or one nature of the discontinuities. Gutenberg and Lehmann, they're called as phase discontinuity, whereas Moho and Birch or Rapidi, they're called as density discontinuity. Mohos and Rapidi, they separate both solids, different density. Okay, so discontinuities can be phase discontinuities or they can be density discontinuity. All good? Or they can be density discontinuity. Any doubts still here, anybody? Any questions here? Any doubts in this? Okay. Let's move on now. So what we know, watch here. What we know, there is a crust. There is a crust. There is upper mantle, middle mantle, inner mantle, core. Upper mantle, middle mantle, inner mantle, outer core, inner core. Okay. This is the chemical differentiation. So my analogy is, okay, Conrad is also an example of density differentiation. It separates the upper parts of the continent which are lighter and the denser one beyond 30, they are a bit more denser. So Conrad is also an example of density differentiation. Okay. Now my example that what I always give is, imagine you have a wall. Wall is made up of bricks. Over the wall, you apply one layer of plaster, cement. Above the plaster, you put some POP. POP, plaster of Paris. Okay, put POP. Above the POP, you put a brownish, what's called as primer. Over the primer, you put maybe some paint, distemper, whatever you want. Okay? These are the layers of the wall. There's a paint layer. Okay, there is a POP layer. There is a plaster layer. Okay, there's a primer, plaster. Okay, POP, and we have the brick wall. ये हुआ composition. Say I want to remove the paint or I want to dismantle the wall. You'll realize even if paint and primer are different, आप उसको पूरा अलग नहीं कर सकोगे आप. They come out together as one layer. Even POP for that matter. Okay, the paint, the primer and the POP, they are so well fused, इनको अलग करना बहुत मुश्किल है. Okay, yes, plaster अलग हो सकता है, brick अलग हो सकता है. So in terms of composition, we have brick, plaster, POP, primer and paint. But in terms of how they act together, the paint, the primer and POP, they act as one layer. Alag plaster, alag bricks. Do you get all of here? Like our skin. Skin is at a very simple level, there are 3 layers. Okay. But आप ये 3 लेयर को अलग-अलग आराम से नहीं कर पाओगे आप. Or imagine, okay, you are baking something. I'm baking, say, paneer. I put some layers on it. Some masala, some coatings, some flour, besan lagaya aapne. The upper layer is so beautifully packed together, you can't separate, okay, the besan from your marinade. Okay, they all stick together. So I say, in terms of composition, they may be different. In reality, this crust and a part of upper mantle, they act as one block. आप इसको अलग नहीं कर सकोगे यार. Okay, and this part of upper mantle is a separate part. Okay, ये अलग हो जाता है, ये भी अलग हो जाता है, and core also separate. So in the chemical composition, the crust and upper mantle are different. But when I talk in terms of hardness, in terms of rigidity, the crust and a part of the upper mantle, the whole thing acts as one unit. इसको बोलते हैं lithosphere. And the remaining part of upper mantle, we call this as asthenosphere. And this up to approximately about 100 kilometers depth tak. Okay, so the crust mantle core is a separate scheme of how we differentiate. Lithosphere, asthenosphere, ये अलग scheme है in how we differentiate. This is the chemical composition. This is the mechanical composition. This is the differentiation based on rigidity in terms of relative hardness. So question was, sir, crust relationship में asthenosphere कहाँ है? Wrong question. Crust, mantle और core के scheme में we don't talk about asthenosphere at all. Asthenosphere आएगा जब आप scheme change करोगे. We call that as the mechanical differentiation. Groundwater, मेरी जान, okay, beta is a very, very small, few meters. Okay, वो तो soil है on the top. और ध्यान देखोगे तो आप अपने आप को भी देख पाओगे, maybe somewhere standing, sitting, running, whatever. No, Abhirup, it's not perception. This is a different scheme. Okay, ये perception थोड़ी है, ये idea in the mind थोड़ी है. It's a part of a scheme on different basis. So give a heading. Yeah. नहीं, solid. Oh, wait, धीरे-धीरे, one by one. Next, give us a heading. Yes. ये P नहीं है बेटा, ये 1 है, 100. This is, okay, from here if you measure up to a depth of 100 kilometers, इसको बोलते हैं lithosphere. ठीक है? Then give us a heading. Mechanical differentiation or differentiation on the basis of rigidity or hardness. Differentiation on the basis of rigidity or hardness. Write down. Okay, number 1, lithosphere. Number 1 is lithosphere. The first 100 kilometers from the surface, the first 100 kilometers from the surface. Next, includes crust includes crust and upper part of upper mantle. The crust and upper part of upper mantle. Next, lithosphere is hard. It's hard. Relatively cooler. It's hard. Relatively cooler. And is broken into segments, into pieces called as plates. Is broken into pieces, segments called as plates. Okay. So if I see this as a large part of the Earth's lithosphere, ये crust हो गया. This is the crust, and this is part of the upper mantle, for depth of about 100 kilometers. This is not one sheet. ये ऐसे टूट गया, it's broken here. This is broken here. Each of these piece, ये एक piece है. This piece is called as a plate. This piece is called as another plate. Okay, the lithosphere is broken into segments called as the plates, lithospheric plates. Okay. Number two, okay, the asthenosphere. This is called as the asthenosphere. Asthenosphere. Asthenosphere is the lower part of the upper mantle. The lower part of upper mantle. So upper part of upper mantle is part of lithosphere. The lower part is separate. It's called as the asthenosphere. Okay, within bracket mention up to a depth of about 300, 350, 400 kilometers. ये यहाँ तक कहाँ तक है ये वाला? Okay, from surface 350, 400 तक. It's called as this part is called as the asthenosphere. Now write down the asthenosphere. The asthenosphere is solid. But is capable of deformations and flow. It is solid, but it is capable of deformations. It is capable of flow. If there are stressors. STRESSOR. Means if you apply force, ऐसे तो this is a solid, definite shape, okay, definite dimensions, it's solid. But if you apply pressure on this, it can deform. Think of sponge. Sponge क्या solid है ना? You apply pressure, it will deform. Remove pressure, it again comes back to own shape. So think of something like that. Now we don't have a separate term for this. So we call this nature as semi-molten. But please, I repeat, ये बार बार आप पूछोगे मुझे. Semi-molten does not mean it is molten. It does not mean it is flowing. It only means that it is solid but can be deformed when there is some strong stress. आपने press कर दिया, it can squeeze. Remove the pressure, it can bounce back. An example is, I said your sponge, soft sponge. Think of a mattress. Mattress is solid. If you apply pressure on it, it, वो deform हो जाता है. Okay, so For the lack of a better word, I call this as semi-molten. Semi-molten कह रहे हैं, but it does not mean it is actually molten. ये उसका property है. Why? Because property है. एक चीज याद रखो, in properties we don't ask why. Water has a density of 1. Why? That's how it is. Gold is yellow in color. Why? That's how it is. उसका property है. Okay. Oxygen is a gas. Why? It's a property. It is gaseous. उसका nature वैसा ही है. The asthenosphere का जो nature है, this is the consequence of the mineral called as olivine. Olivine has this behavior. Write down. Asthenosphere's nature or property is because of olivine composition. Because of olivine composition. No, Priyanka. When I'm saying mantle, imagine यहां से यहां तक almost 300-400 kilometers है. For these kilometers to say the whole thing is homogeneous, that's wrong. ठीक है? So it is mantle, but there are variations in terms of olivine ratios. Okay, we have got more olivine in this part, okay, than olivine in this part. So they are not exactly same composition. There is a difference of variations and they stick together. One becomes lithosphere, the other becomes asthenosphere. Is it okay, all of you? Olivine पूरे mantle में है, but in other parts there are variants of olivine, right? यहाँ पर भी olivine है, but यहाँ को olivine a bit different nature. यहाँ पे olivine है, यहाँ को olivine a bit different nature. उतना detail में I don't need. There are a lot of different type of mineral categories. So I use a general term, we call them as a, we are Indians. एक word में निपटा दिया आपने, right? But Indian, North India, Indian, South India, India, East, West, North, mountains, they're all different. तो ऐसे ही. Although I call them as olivine, but there are variants of olivine. Okay, the one variant we have here, okay, this one has the nature of semi-molten, capable of flowing under stress. But star mark and down, the lithospheric plates float over asthenosphere. The lithospheric plates, they float over the asthenosphere. Okay, that's a term we use. It's part of a theory called as plate tectonics now. Okay, so it's like one layer is asthenosphere, इसके ऊपर में lithosphere है. The lithosphere is not a continuous layer, टूट गया है, and these blocks on this asthenosphere, जो semi-molten है, it's moving, it's floating, and when the plates move, they will interact. You know, such moving plates interact and are responsible for phenomena like volcanoes, earthquakes, mountain building, crustal upliftments, etc. This concept is part of the plate tectonics theory. It's part of the plate tectonics theory. No, Muhammad, no. Astronosphere is not hotter than middle mantle, no. This nature is not to do with the temperatures. It is because of the type of material, the type of minerals, that's all. It's like, my bones are hard and the bloods flow. It's not that my blood is hotter than the bones. Okay? वो nature है blood का, it will flow. Bones का nature है, it is hard. I hope you got the analogy in all of you. So this semi-molten nature is not because of temperature. It is because of the composition that the layer is made up of. Why depth varies? Abhiru, this is not a straight line ऐसे थोड़ी है. Okay, it's a layer like this. So I'm giving a range here. कहीं 300 तक है, कहीं 350 तक, कहीं 400 तक है. वैसे भी I'm approximating. ठीक है? So the nature of the astronosphere is a consequence of the composition of the mineral called as olivine. You heard about watches, right? Okay, we say quartz watch. उसका meaning क्या है? Why is it called quartz watch? Anybody knows? Nobody knows? Some physics guys. It uses a crystal called as quartz crystal. And the quartz crystal has a property. If a part pass electricity in one axis, the crystal will start oscillating on the axis. जैसे oscillate करेगा ये. This is what's called as piezoelectric effect. Correct? Why? Because quartz का nature वैसा है. So quartz nature is you pass electricity, it starts to expand, contract, and it's a very set rhythm. That's why they use in the watches. Whereas olivine का property है, you apply pressure, it will flow. Remove pressure, it again becomes solid. So it is not because of temperature, it's the nature of that particular mineral. Okay, all of you fine here? Okay. Let's move on. So we have lithosphere, astronosphere. Now the remaining part of mantle is called as mesosphere and the core is called as the barysphere. So we have lithosphere, we have the asthenosphere, we have mesosphere, and we have barysphere. We have the barysphere. Mesosphere is middle mantle plus inner mantle. Barysphere is outer core plus inner core. And lithosphere is crust plus upper part of upper mantle. And this is the lower upper mantle. All good? So we'll share some of these diagrams to all of you. Yeah. So this is the upper part of upper mantle. Okay. Continents are different from the oceans. The oceans are made up of basalt rocks. I बताया आपको मैंने. Okay. So this continent plus upper part of our mantle together called as continental lithosphere. The ocean along with upper part of upper mantle is called as ocean lithosphere. And the remaining part is called as the asthenosphere. ठीक है? There's one more diagram I can use to help you remember, will be this one. ये हम आपको शेयर कर देंगे आपको. On one side we have, okay, mantle क्या, outer core क्या है, and the other side I mentioned crust कौन सा है, atmosphere कौन सा है. So this part here. So this is the ocean crust. This is the ocean crust, continent crust. Okay, ये पूरा mantle है. Till here mantle, sorry. यहां से यहां तक mantle. This is the upper mantle. Okay, this is upper mantle. This is also upper mantle. This one is lithosphere, and this is the asthenosphere. ठीक है, all of you, all done? Yes. यहां पर होगा गटनबर्ग मैंटल कोर पे है. ओके, ये अपर मैंटल, लोअर मैंटल, यहां पे मिडिल मैंटल दिखा नहीं रहा है. यू हैव टू हैव वन मोर लेयर एज मिडिल मैंटल. ओके, सो बिटवीन द मिडिल एंड द लोअर विल हैव द बर्च. यस. Yes, so we don't go into that depth. You're right. अगर rigidity है तो why are we keeping the core as one block? It is not a standard classification. In lot of books you'll find core are kept as in an outer core. Some books mention the whole layer as perisphere. Okay, so we just accept that's all. Yes, the rest is solid. Tell me. Islands. It depends on how it was made. If it was made from the ocean crust, उसका अलग nature होगा. Okay, or if it was made from the continent breaking away. So you must tell me the composition. Tell me, then I can tell you whether it was oceanic or. Okay, I'm moving on from here. Now one discussion point here. Nature of the mantle. One small discussion on nature of the mantle. So largely solid. Asthenosphere is semi-molten. Basically, it is capable of deformations. Progressively denser inside. The mantle का nature क्या है? It is largely a solid. The asthenosphere is semi-molten. Okay. I use the word semi-molten not to say it is molten, but that it is capable of deformations. And it becomes more and more dense as I go deep inside. Okay. So upper mantle density about 4, inner mantle about 7, about 9. Okay, the middle mantle about 5 or 6 or 7. As you go down, the mantle becomes more and more dense. Achha. Parts of mantle are molten and can flow. Parts of mantle is molten. Part of mantle is molten and can flow. Okay. Molten mantle magma flows in pathways, flows in conduits. Conduit का मतलब क्या होता है? Conduit means passage. जो molten magma है, I said mantle is solid. Parts of mantle can be molten and can start moving. When it moves through passages, through pathways or conduits. Imagine human body. Human body is what? Solid. Parts of human body is also fluid. Blood is moving, right? How does the blood move? There are passages. Veins hai, arteries hai. You have got lymph also moves. Air exchange hota hai body ke andar mein. But I am a solid person. So mantle solid ही है. But parts of mantle, it can melt and starts moving in passages, pathways. There are conduits. They're like pipes running. You can think of that. Okay. These are called convection currents. They're called as mantle convection currents. Okay. These convection currents, they have circular movements. Parts of the mantle is molten. The molten mantle can start moving. The movement happens through conduits, passages, which is called as convection currents. Imagine, okay, a crust, continents. We have the lithosphere. We have asthenosphere. We have inner mantle. Some part melt ho gaya, and the molten part, okay, can now start, okay, circulating like this. ऐसे घूमना शुरू कर देगा. Like a passage. It's moving like this. They move in circular paths. And these passages can have different sizes. Okay, they can be only in the asthenosphere. They can be even from the deep. So if this is the earth here, like this. So this could be one convection current inside the mantle. They can be larger ones like this. Okay, magma is molten, rising, hits the above layer is here. The above layer is the lithospheric layer. This is the lithospheric layer here. ये पूरा lithosphere है. Lithosphere. Okay, and this magma is rising under lithosphere. It turns, it comes down, and starts mixing. We call these as convection currents. Okay, so magma is solid. I repeat, I'm sorry, mantle is solid, but parts of mantle can also melt and move in passages called as convection currents. Okay, देखा आपने, all of you are done. So they can move as circular movements. That's number one. Okay, number two, extremely fluid mantle magma from deep mantle core boundary can rise as vertical towers called mantle plumes. The mantle hai, when molten, there are two types of movements. One movement is called as the convection currents. The second I'm saying is extremely fluid mantle magma. बहुत fluid है. It can flow very easily. Extremely fluid mantle magma. कहाँ से? From the deep mantle core boundary. From the deep mantle core boundary, it can rise as vertical towers. Rise as vertical towers called as mantle plumes. Plumes. Called mantle plumes. Okay? What I'm saying is this. What I'm saying is, चलो ये तो हो गया convection cells हो गए. What I'm saying is, apart from these cells, imagine this is the core. ये आपका core है. For some reasons, from the core, यहाँ से some lava can generate, some magma can generate, and this can rise up like this, like vertical towers. और ये आके बाहर आके volcanic eruption में. This is not circulating. This is moving, right? This is an example of convection currents. ये ऐसे घूम नहीं रहा. It's just rising like a tower. This is called as mantle plumes. आता कहां से है? From the mantle core boundary, very near from here. Yes. Everything moves through conduits. Conduit कोई अलग से tunnel बना नहीं है. It's like a passage, that's all. Water flowing on the ground. Okay. तो कहीं पर देखो कि पानी का स्रोत बन जाता है ना, वो थोड़ी वहां पाइप लगा दिया आपने. Okay. Whenever mantle moves, the mantle will move through some passages. Okay. और वो passage जो mantle का ही part है. Whenever it's moving, there is some conduits. But this is not moving like circular cells like this. It's going right across, goes up, and it erupts out. We call these as mantle plumes. Yes, correct. Extremely fluid means very low viscosity. It doesn't. Okay, don't use general logic here. बस आपको यही याद रखना, that's all. We are not into geophysics. क्या composition है, what type of viscosity, what velocity, don't require that. Darshan, because this magma is enormous magma. Some amount does come out, but the rest is not able to come out. It spreads under the lithosphere. This one can move through gaps, passages, some joints. It can move and come out very slowly. All done, all of you? So, what are mantle plumes and what are convection cells? आप एक point add कर लो that mantle plumes are localized. Mantle plumes are localized. They can form anywhere under the continents or under the oceans. They can form anywhere under the continents or under the oceans. They are always associated with very basaltic lavas. They are associated with very basaltic lavas, very fluid basaltic lavas. Very fluid basaltic lavas. एक और point add करो. They can create volcanic islands on the oceans. They can create volcanic islands on the oceans, like Hawaiian Islands. Like Hawaiian Islands. Sorry. Hawaiian Islands. Okay? So, mantle plumes are not same as convection currents. Convection currents are much more larger. Okay. They can break the continents or oceans apart. इसका अलग कहानी है पूरा. But these are more localized. Smaller होते हैं compared to these ones. You can add one more point that many mantle plumes can convert into convection cells. Can convert into convection cells. And over time, it's possible that this one ultimately can become a convection cell. Okay. But not always necessarily. It's like, sometimes one small prick can convert into a major wound. Because zaruri nahi hai, every prick will become a wound. One small cut sometime can become an infection. Okay, it's a major one then. But not all cuts will become infections. Think of those lines. Okay? So, some of these can convert into large convection cells. Okay. So, lot of convection cells beginnings are mantle plumes. But not every mantle plume becomes a convection cell. Yeah? Yes. Convection cell है तो is always because circulation चल रहा है. It's like think of the air in the room. अब यहाँ पर अगर कोई हीटर लगा देते हो, air will rise, hit the roof, it'll diverge out, it'll cool somewhere, it'll sink down. जहाँ पर warm air है और low pressure बन जाएगा, again it comes back, it always will circulate. अरे conduit कोई अलग से पाइप नहीं है. It's not a tunnel made. Okay, it's like think of this book is solid iron. और आपने यहाँ पे heating शुरू कर दिया. Very strong heating here. That heating probably can melt the iron above, and maybe this part melts. थोड़ी आपने यहाँ पे पाइप बना दिया. For imagination, I'm saying, that it looks like the molten is moving through some conduits. Essentially, it is pathways how they are circulating, but not a separate one like a tunnel. Yes, correct, yes. Yeah, anybody else? How does magma flow upwards? Krish, something is hotter, it'll expand, it'll become less dense, it will rise up. तो इतना हीट चाहिए, राइट? आस्किंग मी, इतना प्रेशर है तो कैसे राइज कर रहा है? इतना प्रेशर है उसके बाद भी राइज करेगा, मतलब क्या? इट्स सो हॉट, इट इज सो लाइटर, इट कैन पुश द rocks and start moving upwards. Okay, anybody else here? So what is mantle? Okay. What happened? You guys can see the screen? Yeah, whatever. Yeah. Yes. Because उतना गर्म हो चुका है. It is one pressure acting like this. This is so hot, molten. Okay, molten will become lighter. It's able to counter the weight. That's it. You cannot see the screen. Okay. क्या हो गया? ठीक ठाक था अभी. Just a minute. ऑलमोस्ट डन वैसे भी. या जस्ट गिव मी अ मिनट. यस. हाँ, इतना गर्मी, इतना मैग्मा होगा तो जल ही जाएगा कुछ ना कुछ. मे बी बिकॉज ऑफ दैट. क्या हुआ देखो. इसको बंद कर दो. हाँ.